Okay, checking these critical numbers on our calculators. So I'm going to go back to question number one. Make sure you stay tuned for especially the trig one. Um, Now, critical numbers are where the derivative equals zero. So that would mean, or undefined. So that would mean you would see like a top of a hill, bottom of a swale, or maybe a corner that's undefined, or maybe even it just gets to zero and goes back up. So that's what all you're looking for in your graphs to see, what if any of that stuff happens. So I took my calculator and I'm graphed all these. The one I have showing now is this one. When you hit graph, I see that there's a little valley here at x equals zero, so that looks good. The 3/10 I don't really see, but maybe it's up here somewhere. Let me zoom out. That's horrible. So I'm going to zoom in, but I'm going to zoom into like at x. See my x value. See my x value. When I zoom in, I'm going to try to get towards 8.85. Actually, let me do it this way. Zoom standard is our regular zoom. Let me zoom in up here. Zoom in and move my cursor up to this area. Sorry about that. You can see my cursor. I'm zooming in there. All right, so you can see this is very, very, very subtle. I'm going to zoom in a little bit more. To this area. And I can probably see what's going on here. It's a very, very subtle change, and I just screwed it up. I don't know what I did. And this is the process you may have to go through when finding these. So I don't mind it taking a while. But do you see the graph goes zero here and then dips down a little bit and goes back up? Well, that's where it's 3/10. Now, if you really want to check that out, it looks like it might be a minimum there. So second calc minimum. I don't want to go over here because I don't want to get zero involved. I already know that's good. So I'm going to start left bound right here after zero. Right bound just right over here somewhere. And enter for a guess. You see that the x value is 0.3, which is the 3/10. So that was kind of a tough check because the graph was just so compact around those 2 points. Hopefully this one's better. So I also graph that in advance. So I'll turn off this graph and turn on this graph. When you graph this one, if your zoom's out of whack, because you saw I was playing with it, I'm going to zoom 6 to get the standard zoom. And you can see that this graph is just like that. There are no critical numbers here. Zoom out a little bit. Zoom 3, enter. And this graph is like a hyperbola. It's always going up. So there's no place that you're actually going to get a horizontal tangent line. And you can see it has its vertical asymptote at around -7. So there are no critical numbers. The next one, which is that really, really complicated one. So I would figure the graph is going to be complicated. Let's see. Turn off this one. Turn on this one. This is what the graph looks like. Zoom. Standard 6. Oh, that's horrible. We'll do the best we can. So I'm going to zoom in on this. That's not bad. So we have our critical numbers right. 0, plus or minus root 2 over 3, and plus or minus 1. So when you look at this graph, you'll see 0 is good. These are plus or minus 1, so this and this are both your plus or minus 2 root 3. And what's happening at 1 is, take a look at this graph. What's happening at 1 is, and the graphing calculator doesn't show it very well, but the tangent line is going vertical, which means undefined. So here's negative 1, 1, those are vertical. Root 2 over 3, negative root 2 over 3, horizontal, and 0. So that confirms our results. And finally, I'm going to look at the trig one. This one, if you remember, I'm going to zoom trig. And then you can get a lot about this graph based off that, especially the answers on the unit circle. So I'll remind you of that while we're looking at this graph of 4 cosine x plus 2x plus 1. Here's the graph. This one I'm going to make a point to zoom trig. So zoom 7. I'm going to extend my y because it looks like it peaks up here, and I don't want to screw up the whole zoom, the x-axis. So now I'm going to hit window and my y max, so the graph goes up a little bit more. I'm going to change to, say, 8 and regraph it. That's perfect. So according to this graph, I should have critical numbers right about here and here. So if you extend this down, and this isn't the best way to do this graph, but I guess it's not bad. Extend this down. These are the two critical numbers. Now, if you remember, from here to here is the first quadrant. From here to here is the second quadrant. Here to here is the third and fourth. So according to this, it happens late in the first quadrant. I'm sorry, that's not late, that's early. Here's the point. It's early in this quadrant. So that corresponds to, if you go around the quadrant, the first spoke. It's pi over 3. And in the second quadrant, which is here, our point happens late within the quadrant, which corresponds to the second spoke in the quadrant. First, second. We're always going around this way, remember. So this corresponds to pi over 6 right here. And this corresponds to 5 pi over 6. So that's a great check. So hopefully that's going to help you. And I'll see you during the live portion.